6 million wild boars, 2.5 billion in destruction, every single night across America. But while most farmers watch their life's work disappear into pig stomachs, a select few have cracked the code. They're achieving success rates that seem impossible. 94% effective against an enemy that outsmarts million-dollar technology. Their secret? It's not what you think. Right now, somewhere in Texas, a farmer is using a 10,000-year-old method that AI systems can't replicate. In Brazil, a man with nothing but a shovel triggered a revolution that saved entire regions. And deep in Arkansas forests, 8 dogs are accomplishing what helicopters costing $4,000 per hour cannot. These aren't just survival stories. They're masterclasses in human ingenuity when everything conventional fails. What you're about to discover will fundamentally change how you see the relationship between intelligence and instinct, between ancient wisdom and cutting-edge innovation. The war for global's farmland has produced some shocking winners, and their methods will surprise you. But the ultimate question lingers. How will the world face millions of wild boars? By protecting fragile ecosystems, or by turning them into a meal on every table? Stay with us until the end, because the truth will leave you astonished. Most farmers think 7,000 volts will stop anything. They're wrong. What wild boars do when they encounter electric fences will shock you more than the voltage itself. When wild boars arrive, they demolish everything, obliterating cornfields in minutes, transforming orchards into wastelands, excavating anything their remarkable noses detect beneath the soil. Tom Richardson, a third-generation rancher from East Texas, explains the reality. People think we're just stringing up wire, but this is psychological warfare. These hogs remember pain better than most animals remember food. You deliver 7,000 volts once, really make them feel it in their bones, and that memory burns into their brain. But after 30 years doing this, I've watched them learn faster than we're adapting. The sophistication of these electric barriers would surprise most people. Multi-layered shock corridors, each wire precisely calibrated, posts no more than 12 feet apart, heights calculated to catch everything from 30-pound piglets to 400-pound boars. The electrical current pulses every 1.2 seconds, delivering enough neurological disruption to create lasting aversion. But what happens when even 7,000 volts isn't enough? That's when farmers face their darkest choice. 2 substances remain legal for wild boar control: warfarin and sodium nitrite. But poison creates new problems. Poisoned boars can travel 8 miles before dying, contaminating vast areas. Scavengers feeding on carcasses spread toxins through the ecosystem. Non-target species accidentally consume bait. You think we want to use this stuff? Richardson continues. When you've lost $200,000 in crops and your bank's threatening foreclosure, you make choices you never thought you'd make. But poison's becoming useless too. Smart sows are teaching their young to avoid bait stations. Without aggressive intervention, the wild boar population doubles every 18 months. This urgency drives farmers to their next desperate move: trapping. But 73% make a catastrophic mistake that turns their properties into education centers, teaching entire boar families to avoid humans forever. When modern trapping fails and technology becomes the enemy, some farmers are rediscovering methods that predate written history. These aren't solutions for massive populations. They're surgical strikes that work where everything else fails. Deep in Alabama forests, the earth suddenly drops away. A pit trap, unchanged in design for millennia. 4 feet deep, 6 feet wide, walls angled inward at precisely 15 degrees to prevent climbing. One miscalculated step, and a 300-pound boar plummets into darkness. No batteries, no maintenance, no technological signature for smart boars to recognize. The real mastery isn't in digging, it's in placement. Experienced farmers spend weeks studying boar highways, invisible trails worn by generations between feeding and bedding areas. They identify bottlenecks where animals have no choice but to pass through specific points. Construction requires surprising sophistication. Pit edges must support a latticework of branches strong enough to hold debris, yet fragile enough to collapse under 180 pounds of pressure. Some farmers use weave patterns passed down through families, each strand calculated for exact failure points. Thong-long snares offer another ancient solution: steel cable loops suspended 10 inches high, the exact height of a boar's mid-stride. Loop size matters. 9 inches for young boars, 12 inches for adults. Too small, and they step over; too large, and they walk through without triggering. These methods work precisely because boars have learned to fear technology but trust nature. A hole covered in leaves registers as natural until it's too late. But primitive traps can only eliminate individual boars one at a time. When farmers face entire sounders of 20-30 animals destroying hundreds of acres, they need industrial-scale solutions. This desperation drives them toward the most expensive trapping equipment money can buy, and into the catastrophic mistake that 73% of farmers make. When facing entire sounders destroying hundreds of acres, farmers turn to industrial-scale solutions. Each year, American farmers invest $190 million in sophisticated trapping equipment. Independent studies show 73% of it fails completely. Not because the traps are defective, but because farmers don't understand the intelligence they're fighting. Mark Sullivan learned this lesson expensively. I spent $15,000 on the biggest corral trap money could buy. 40 feet wide, 8 feet tall, automatic gates, cellular cameras, everything. First week, I caught 2 piglets. The adults watched from the tree line, learned the danger, and never returned. Meanwhile, they destroyed my soybean field next door. $30,000 gone in 3 nights. But there exists one method that wildlife experts unanimously agree represents trapping's pinnacle, capable of capturing entire sounders of 20-30 boars in single activations. Success rates exceed 85% when properly executed. The specifications seem excessive. Minimum 35-foot diameter, 5.5-foot walls, remote-triggered guillotine gates, reinforced with 4-gauge wire panels. But the physical structure is just the beginning. The real secret lies in conditioning protocol, psychological manipulation so precise it resembles military intelligence operations. First comes pre-baiting, 5-7 days of free feeding with gates wired open. The bait isn't random. Fermented corn soaked exactly 1 week until lactobacillus bacteria create odors detectable from 2 miles away. Cellular cameras monitor every visit, using AI to count individuals and identify the matriarchal leader. Wild boar societies are matriarchal. Capture the lead sow, and you've captured the sounder. Miss her, and she'll teach 3 generations to avoid that location forever. The triggering decision requires nerves of steel. Even with 15 boars inside, if the matriarch remains outside, experts wait. One premature closure creates trap-educated survivors who spread avoidance behavior through scent marking and behavioral teaching. When execution comes, it happens at 2 a.m. via cellular signal. The gate drops in 0.3 seconds, faster than pigs can react. But here's where most farmers fail again. Those screams aren't just noise. They're sophisticated alarm systems encoding danger information. If trapped boars remain caged longer than 4 hours, every wild pig within 3 miles receives a biological telegram. Death trap at these coordinates. Successful trappers arrive before dawn, dispatch animals quickly, then do something unexpected. They clean everything. Blood, hair, even scent molecules are washed away with enzyme cleaners. The trap moves at least 100 yards. Some spread fresh dirt to eliminate trace pheromones persisting for weeks. The economics reveal the stakes. Properly executed operations cost $111 per animal. compared to $50 in nightly crop damage per pig if left unchecked. Yet even perfect execution faces limitations: road access requirements, flat terrain needs, extensive setup time. But in Brazil's impossible terrain, where bedrock prevents digging and slopes block machinery, one desperate farmer with nothing but determination sparked a revolution that's spreading across 3 continents. If you found this video fascinating and worth watching, comment 1 below. If not, be honest, comment 0. While American farmers spend $190 million on complex trapping systems, one Brazilian farmer with a shovel sparked a revolution that outperformed million-dollar technology. His insane idea saved an entire region. João Ferreira stood in his destroyed sugarcane field in 2018, calculating ruin. 2 consecutive harvests obliterated, $140,000 in losses, 3 bank foreclosure notices. Technology had failed. Sophisticated traps meant nothing. All he had left was a shovel and an idea everyone called crazy. Digging a moat around my farm like some medieval castle, João recalls, hands still bearing calluses from those first trenches. But when you're watching your children's future disappear into pig stomachs, crazy starts looking rational. I knew pigs could jump fences, break gates, even learn to avoid traps. But could they fly? Could they climb vertical walls? Simple physics said no. The trenches he carved, 1.5 meters deep, 1 meter wide, walls cut at 90-degree angles, took 3 months to complete by hand. 20 kilometers surrounding 80 hectares. His body broke down twice. His wife begged him to stop. Neighbors gathered to watch what they assumed was a mental breakdown. Then the impossible happened. Within 2 weeks, crop damage dropped 85%. By week 4, 0 intrusions. Not a single boar breached the defensive line. Word spread through WhatsApp groups and farmer cooperatives. Within 6 months, entire communities mobilized. Villages pooled resources for excavators. Agricultural zones coordinated trench networks spanning hundreds of kilometers. One desperate farmer with a shovel became the Trincheira Revolution. The engineering evolved rapidly. Farmers discovered trenches needed specific angles: 75 degrees in clay, 90 degrees in rocky soil, concrete reinforcement in sand. Drainage systems prevented flooding. GPS mapping ensured no gaps. The economic transformation was staggering. São Carlos village invested $400,000 in communal trenching, saving $3.2 million in crop damage the first year. Insurance premiums dropped 60%. Land values increased as buyers sought protected zones. But the rainy season brought challenges. Torrential rains turned trenches into rivers. Mosquito populations exploded. 3 tractors crashed during night operations, causing $200,000 damage. A child nearly drowned in a water-filled trench. Community innovation solved everything. Farmers installed French drains, perforated pipes covered in gravel, maintaining barriers while allowing water flow. Solar-powered LED strips marked bridges. Ladders were placed every 200 meters for emergency escape. Some introduced tilapia fish to eat mosquito larvae, creating unexpected aquaculture income. The most remarkable development was social. Communities that competed for generations began cooperating. Trench maintenance synchronized. Breach alerts spread instantly through communication networks. When defenses failed, neighbors arrived with equipment and labor. These trenches didn't just protect our crops, João reflects, overlooking thriving sugarcane fields. They transformed us from individual farmers barely surviving into a united force. We proved that together, with nothing but shovels and solidarity, we could engineer solutions that million-dollar technology couldn't provide. The Brazilian model has spread to Argentina, Paraguay, and Texas. Agricultural engineers study these hand-dug defenses, amazed that primitive concepts outperform modern solutions. But trenches only work where you can dig. In America's rocky highlands, where bedrock lurks inches below surface and slopes exceed 30 degrees, farmers embrace the most extreme solution imaginable: aerial warfare that costs $4,000 per mission and demands nerves of steel, turning the sky itself into a battlefield at $4,000 per mission. $4,000 per mission, 80 miles per hour, 30 feet off the ground. When trenches can't be dug and traps fail completely, farmers turn the sky itself into a weapon. This is agriculture's most dangerous battlefield, where one mistake means death. In terrain where volcanic stone lies inches beneath soil and slopes exceed 30 degrees, traditional methods become impossible. Bedrock breaks excavator teeth. Root systems form underground walls. Here, farmers face an ultimate choice: abandon everything or embrace aerial warfare. Helicopter hunting represents the most extreme solution in wildlife management. 2 hours of combat aviation against an enemy that knows every hiding spot across thousands of acres. Operations begin before dawn. Thermal imaging identifies heat signatures across vast territories. Helicopters launch at first light when boars return to bedding areas, exposed in open ground. What happens next defies civilian comprehension. Pilots spot sounders, maybe 20 animals, and drop into attack position. Rotor noise sends them scattering, but from above, there's no escape. Gunners armed with AR-10s firing 308 rounds begin systematic elimination. Each shot calculated for instant kill. Within 8 minutes, entire sounders that terrorized farms for months cease to exist. The efficiency is stunning. One crew eliminates 60 to 80 boars per flight, preventing $200,000 in agricultural damage. Texas aerial hunting removed 27,000 boars last year, 8 million in prevention. Yet this aerial supremacy comes with brutal costs. Mechanical failures over forests means certain death. Power lines hidden in morning fog claim lives regularly. These operations require combat veterans, former military pilots who understand every flight might be their last. But even these aerial solutions face limitations in bad weather and dense forests. That's where farmers discovered something that makes helicopters look primitive: artificial intelligence that predicted a boar invasion 3 days before the animals even decided to move. While helicopter crews risk their lives in aerial combat, the smartest farmers discovered something even more powerful: artificial intelligence that predicts boar invasions 3 days before the animals decide to move. At 2:47 a.m. in Louisiana, darkness, a thermal drone hovers silently at 400 feet, scanning 200 acres per minute. Suddenly, algorithms detect 18 heat signatures moving through dense undergrowth, invisible to human eyes. The AI identifies them as wild boars with 97% certainty, predicts their movement pattern, and automatically alerts ground teams to intercept positions. Welcome to the future of wildlife management, where machines don't just watch, they think. David Chen, former Silicon Valley engineer designing agricultural defense systems, explains the revolution. We're engaging in predictive battlefield management. My AI learns from every encounter, tracks family groups across months, predicts their next move based on weather, food source, and historical patterns. Last week, it prevented a major incursion by identifying that barometric pressure drops trigger migration toward cornfields. We positioned defenses 3 days before the boars decided to move. The technology stack reads like military specifications. Thermal cameras detecting 0.05 degree temperature variations. Drones with 8-hour flight times, autonomously patrolling predetermined routes. Ground sensors creating invisible perimeters triggering when specific weight and heat combinations pass through. Modern systems use convolutional neural networks trained on millions of wild boar images, distinguishing between boars and deer with 99.3% accuracy even in heavy rain or fog. They track movement patterns across weeks of surveillance. The most ambitious project operates across 50,000 Texas acres. A network of 400 cameras, 50 drones, and 2,000 ground sensors feeds data into a central AI system processing 10 terabytes daily, creating a living map of wild boar activity. When detecting incursions, the system instantly alerts farmers positioned in strategic ambush points. Drones provide real-time surveillance, guiding hunters to optimal shooting positions. The combination of AI prediction and human precision creates lethal efficiency. Boars are eliminated before they can damage crops or escape. Results border on unbelievable. Properties using integrated AI systems report 94% damage reduction within 6 months. One Florida ranch eliminated 300 boars through perfectly coordinated ambushes. The AI predicted movements so accurately that farmers were always in the right place at the right time. But while Silicon Valley engineers perfect AI algorithms, something ancient is happening in Arkansas forests. A man with 8 dogs just cleared 50 wild boars using nothing but 10,000 years of evolutionary partnership, proving that sometimes the oldest technology is still the most powerful. While farmers spend millions on AI and thermal drones, Ray Thompson and his 8 Catahoula leopard dogs eliminate 40-50 wild boars annually using nothing but evolved partnership. Before dawn breaks over Arkansas mountains, you can hear them, baying hounds echoing through valleys in primordial pursuit. People forget that the best sensor ever created is a dog's nose, Thompson explains. My lead dog, Moses, can smell a boar from half a mile away, track it through water, distinguish between a 100-pound sow and a 300-pound boar just by scent. No computer can do that. The process is methodical. Dogs spread across terrain, noses analyzing scent molecules that tell complete stories. Animal size, direction, how recent the trail. When one finds fresh sign, its voice changes to a specific pitch experienced hunters instantly recognize. Dogs work specialized roles. Bay dogs chase and corner prey. Catch dogs physically engage and hold. Lead dogs coordinate pack movements. The system relies on thousands of years of selective breeding, creating animals specifically designed for wild boar hunting. When dogs corner a boar, hunters have seconds to arrive and dispatch the animal before razor-sharp tusks injure their partners. This demands split-second coordination between human and canine intelligence. The effectiveness astounds wildlife managers. Traditional dog hunting accounts for 35% of wild boar removal in forested regions, despite representing less than 5% of management budgets. Where drones can't penetrate dense canopy and AI systems fail in electrical storms, dogs navigate effortlessly. Universities now study these partnerships, discovering that canine sensory capabilities combined with human strategy creates efficiency no technology replicates. In terrain too rough for vehicles, too dense for aircraft, too complex for traps, dogs succeed where million-dollar systems cannot. But when the last shot is fired and the hunt ends, farmers face a challenge no one talks about. What to do with hundreds of pounds of wild boar carcasses that could spread disease if handled wrong. The hunt ends with the last shot, but the real responsibility begins immediately after. Wild hogs taken down must be handled quickly and properly. The most common method is mass burial. Trenches over 1 meter deep are dug with machinery. Carcasses are buried within 4 hours to prevent disease, odor, and scavenger activity. In hot climates, delays can accelerate decomposition dangerously fast. Some states permit cremation or composting, but only with special licenses and proper biosecurity equipment. Once disposal is complete, USDA Wildlife Services and local agencies may inspect the area. They check for residual animals, fresh tracks, or signs of surviving hogs. Soil and water sources may be tested for bacteria or viruses. Only then can an area be marked clean. And even then, vigilance must continue, many hunters ask. Can the meat be eaten? Yes, but only under strict precautions. Wild boar meat often carries parasites and dangerous bacteria like Trichinella spiralis, causes trichinosis. Brucella suis, affects internal organs. Leptospira, an African swine fever virus. Due to this, wild hog meat is banned from commercial sale in many regions. Only private consumption is permitted, and even that requires proper preparation. To make wild boar meat safe, hair removal, singe using flame torches, then scrape, butchering. Cut quickly and refrigerate below. Fornfordiduro, cooking, to reach internal temperature of at least 160 moro. Stews, roasts, or pan-seared cuts are effective if fully cooked. Undercooked meat risks transmitting parasites to humans. Some choose not to consume the meat at all. Others donate it, where legal, to trained processors. But one rule always applies: respect the meat or don't eat it. Would you cook and eat wild hog, or bury it and move on? Let us know your take in the comments. The battle against the wild boars has revealed something profound about human nature: that our greatest strength isn't in the sophistication of our technology, but in our ability to adapt, learn, and never surrender in the face of overwhelming odds. From Santos Francisco's simple trenches to cutting-edge AI systems, each solution represents generations of farmers who refuse to give up on the land that feeds us all. These aren't just pest control methods. They're testaments to human ingenuity, perseverance, and the quiet courage of people who wake up each morning determined to protect what they've built. The next time you see farmland, remember, behind every acre lies someone's unwavering commitment to never stop fighting for what matters.